How do you test a belief or claim from a statistical perspective? Well, the inferential technique in order to do that is called a hypothesis test. And you're going to learn a number of different hypothesis tests, but we're going to start off with the simplest case where you are testing a belief or a claim about a single aspect of the population. And that aspect is either going to be something about the mean or about the proportion. And so there's a number of steps to hypothesis testing, but I'm going to break it down in my videos. And this video is going to focus on the first step, which is stating hypotheses. Now, for every hypothesis test, there are two hypotheses. There's your null hypothesis, which tends to be the boring scenario, the scenario where you don't learn anything new. It's as you might have expected. And the alternative hypothesis tends to be the more interesting one. Now in homework, and oftentimes you might see in problems that you need to try to identify the claim in your hypotheses. In practice, more often than not, the claim is going to be your alternative hypothesis. But as you'll see in some of these examples, it could be that the claim is the null hypothesis. And the way that you will identify that is if the claim has the possibility of being equal to some value, whether it's equal, less than or equal to, or greater than or equal to, and then that's going to be in your null. But if it's a strict inequality, meaning a less than or below, under, if it's greater than, or above, more than, or not equal, meaning less than or greater than, then that sign, that claim is going to be in your alternative hypothesis. And so understanding those different mathematical symbols, less than, greater than, not equal to, greater than or equal to, less than or equal to, is going to be important, especially converting English into the corresponding mathematical symbol. And so let's take a look at number one here. Is the average amount of time that a person spends reading the newspaper equal to 22? So as I read through this and I realize, okay, our investigation is trying to answer this question. This question is about an inference with respect to an average. So I know my hypotheses are going to have mu in it. And I could see the relationship of equal. So this is going to be an equal, not equal scenario. The signs in your two hypotheses should complement one another. In other words, they should cover all possible values. And so if one is equal, the other has to be not equal. If one is less than, the other must be greater than or equal to. If one is less than or equal to, the other one must be greater than. Right. So in this one, our hypotheses should look as follows. So your two hypotheses, the null is written with an H subscript 0, and the alternative is written with an H subscript 1. Some of you may have past experience with statistics, and so you may have seen or you may encounter this as an H sub A, capital or lowercase, it doesn't matter. And that's true, they're one and the same. I tend to use H1, but if for some reason you are familiar with or more comfortable with H sub A, feel free to use that notation. And so what's important here is to notice two hypotheses, H0 and H1. Notice that mu is in both of them, which it should be the same parameter. Notice that equal goes in your null hypothesis. The complement, which is not equal, goes in the alternative hypothesis. And the value that we are hypothesizing with respect to is 22, which is the same number in both of the hypotheses. So not too bad, but let's look at a few more. In number two, is the percentage, all right, so percentage, which means this is going to be with respect to P, is the percentage of college students who eat pizza each week less than 12%. So this tells me a few things. One, I'm going to be using P, and two, I want a less than sign, and I want the complement, which is a greater than or equal to sign. And P is going to be related to 12% or 0.12. And that's how I place it. So remember, P is on the left, or the parameter is on the left. The value is on the right. The symbol with the equality aspect is in your null hypothesis. And then the inequality is in your alternative hypothesis. So less than is strictly less than. It's a strict inequality. That goes in your alternative, and the complement must be in your null hypothesis. Third example, the average number of chemical reactions that take place in the human body during an hour of REM sleep is approximately 124,000. So average, that tells me that we are looking at inference about mu as it relates to 124,000. And the word approximately is signaling to me that it's close enough or different from. So close enough means, is it essentially equal to? And different from means it could be something else, but something else either below or above. So that description should make you think of equal and not equal. And that's what you should have in your hypotheses for this example. Take a look at number 4 here. Is the average length of a television commercial break longer than 3 minutes? All right, longer. So average, longer, that's strictly greater than. And this is the value we're comparing to. So I should have a mu. I should have a mu greater than 3 in the alternative. And that implies a mu less than or equal to 3 in the null hypothesis. I want to jump to the next page and look at 14, 15, 16. We'll do them in order. 14, is the percentage of food a sloth eats per day equal to 17% of their body weight? And so here you've got inference is going to be with respect to a percentage, which is P. Is it equal to or not equal to this value? And so hopefully you're able to figure out that this one is going to look like this. P equals 0.17 versus P is not or is different from 0.17. For 15, the average weight loss for an astronaut on the moon is no more than 115 pounds. This one's a little tricky. Average, that's mu. 115 pounds is what we are relating to. No more than means it's less than or equal to. So it could be up to 115. So the less than or equal to must go in your null hypothesis, which leaves the complement or greater than in your alternative. And so for 15, what we are investigating happens to be the claim in the null hypothesis. Whereas most of the others or all of the others have been in the alternative. Finally, 16, do the majority of Americans hope that a female will be president one day? So majority, you're looking for most, you're probably investigating a percentage or proportions. That implies P is our parameter of interest. And here, the value we want to compare to, well, either they are for or hope for a female president or they aren't. And so if it's a majority between two choices, then that means, is it more than 50% or not? And so that's the hidden value in this scenario, because 0.5 isn't clearly in there, but the word majority implies that. So P greater than 0.5 must be in the alternative, and P less than or equal to 0.5 has to be the complement in your null hypothesis. At this point, I'd like for you to pause the video and attempt to determine the hypotheses for the remaining ones that I had hidden in blue. And then when you're ready, feel free to start the video back up again to see the answers. Let's see how you did. I am going to unhide them as we go through. For number 5, The proportion of Americans who gamble more than once a year is 0.8. So proportion P implies equal, and the value we want to know is it equal to is 0.8. P equals 0.8. So that's going to be in your null hypothesis with P not equal to 0.8 going into your alternative hypothesis. 6, the average score on the STA 2023 final exam is less than 84. Average is mu less than 84. Mu less than 84 has to go in your alternative hypothesis, which implies that mu greater than or equal to 84 is going to be in your null. Remember, the symbol with the equality component must be in your null hypothesis. 7, do the average number of weekly posts to social media by college freshmen exceed 100? So average mu exceed greater than 100. Mu greater than 100 must go in your alternative with mu less than or equal to 100 in your null hypothesis. Moving on. Has the percentage of pole vaulters in the US decreased from 38%? So percentage P decreased less than 38% or 0.38. So P less than 0.38 must go in your alternative with P greater than or equal to 0.38 in your null. 9, is the average age of journalists who are published in New York Times above 30, mu greater than 30 versus mu less than or equal to 30. 10, is the probability of selecting a female from a litter of puppies greater than 50%? Probability P greater than 0.5. P greater than 0.5 versus P less than or equal to 0.5. For 11, I realized that there's an equal and a greater than. I think what I had meant for was greater, but if you happen to do the equal, I'll talk you through that. And so if it's greater than, here we're looking for mu greater than 1 versus mu less than or equal to 1. If you happen to go with an equal sign, you should have mu equal to 1 versus mu not equal to 1. And if you had, for some reason, assumed that equal and greater were flipped and it should have been greater than or equal to, then you'd have a greater than or equal to sign in your null hypothesis with a less than sign in your alternative. 12, on average, students take STA 2023 2 times. And so mu equals 2 versus mu not equal to 2 is what I'm looking for here. And finally, the last one that we haven't gone through, the average cost of a criminal court proceeding is $5,678. So average is mu is equal to 5,678 versus not equal to. And hopefully at this point, you're feeling fairly comfortable with figuring out how to state your hypotheses. I'll warn you that the most common mistakes, other than possibly getting your symbols wrong, is not writing a parameter. So some of you may eventually put X bars in or P hats, but your hypotheses should always be in terms of your population parameter of interest. It doesn't make sense to hypothesize about the sample because in practice you would have the sample, and so you know what X bar and P hat are. You don't need to guess at it. You could calculate it. So next video is going to take you into another step of hypothesis testing, and we are going to focus on finding critical values.